Welcome to the webinar on water management in saline agriculture, organized jointly by the Icid, FAO, ICBA, and the African Young Professionals Forum, African Regional Group of Icid. It's indeed a matter of great pleasure that we have today, that we have the presence of our President Felix Reinders and three of our Vice Presidents or Vice Presidents Honorary, as well as FAO, who is our main supporter in all our technical activities, and also from ICBA, who are also working with Icid in many other areas. So, at the outset, I will go through a brief of the program. The program is that we will be having opening remarks by President Felix Reinders. Then we'll be having about 15 minutes presentation on WASAJ Working Group on Saline Agriculture by Dr. Jean Boroto, Senior Land and Water Officer of FAO. We will be having another presentation from Dr. Marco Arcieri on water resources management in salt-affected areas. Management of saline and brackish water will be presented by Dr. Ragab, Vice President Honorary Icid. Then we'll have saline farming, a presentation by Dr. Lyra from International Center for Biosaline Agriculture, ICBA. We'll be having a small time for audience discussion, questions and answers. And then we'll also have a small brief of 10 minutes by Dr. Mohamed Wahba, Vice President Honorary Icid and Chairman of African Regional Group on various aspects of the African Young Professionals Forum, as well as various other activities that we want to undertake, especially around Africa. So for this, we will have the questions and answers for after the presentations, or after all the presentations are over, we will take the questions and answers. I will encourage the participants to type out their questions so that those, and by addressing specifically to the particular so that it is possible for the concerned speaker to answer those questions and satisfy your queries. We would also request you, if you want to share your experience, you can raise your e-hand, and that e-hand small symbol is there on your side, which you can raise, and then we may be able to give you some time. So now, at the beginning, I will request, I will also request all the presenters to, when their presentation comes, at that point of time, they can share their screen with their PPT, so that the PPT can be shown, and then you can carry out with your presentation. So now at this point of time, I would request all the presenters to kindly switch off their videos, and we will have the video of the current presenter on the screen in order to conserve the bandwidth. So at the outset, we will have the pleasure of hearing our opening remarks from President Felix Reinders, who is the President of Icid. He is a professional engineer with 36 years of experience in the field of agriculture and civil engineering. He holds specialization in water resources management and irrigation engineering, and he has completed his studies from the University of Pretoria, South Africa. He has authored many scientific and semi-scientific papers and articles in the field of irrigation. And he is also a visiting lecturer at UNESCO IHE Institute for Water Education, where he imparts knowledge on design and operation of drip and sprinkler irrigation systems. He has been actively involved in the establishment of South African National Committee on Irrigation and Drainage. Hello. And he has also served as Vice Chairman Icid from 93 to 99. Dr. Felix hardly needs any introduction in the irrigation and drainage field. And now we will request Dr. Felix to please give his opening remarks for the seminar.
Thank you very much, Secretary General. I just wanted to share my screen. Share my screen. Can everybody see the screen?
Yes, sir, we can see you, sir.
The other, I can't see my own screen. I must take away the. Oh, there we go. Excellent. Normally we say, dear delegates, and while you're all now webinar delegates, most probably it is Webigates. So it is a privilege for me to say a few words, and I've titled my remarks, Irrigation and Drainage, Water Management in Saline Agriculture. Now, of course, I would like to address a few issues. First of all, just some introductory remarks. Then some words about Icid, because I believe many of you, it's the first time that you interact with the International Commission on Irrigation and Drainage. Then, of course, due to the fact that it is mainly the young professionals from Africa that we are talking with, I would like to share some figures of Africa, and then some remarks on water management in salt-affected agriculture, and then finally some concluding remarks. So first of all, the International Commission on Irrigation and Drainage. The organization started in 1950 with 11 countries, and as it is now 2020, we actually celebrate our 70th anniversary. And the foundation took place on the 24th of June 1949. So it's 71 years of the foundation of the International Commission on Irrigation and Drainage. And we are a proud network of professionals all over the world, national committees, individuals, with the vision to promote sustainable agriculture, water management, to achieve a water-secure world free of poverty and hunger through sustainable rural development. And we represent more than 75 countries. That is a representation of 90% of irrigated agriculture. And in our vision, you will see we got 6 goals, and they address certain aspects in terms of enable high crop productivity with less water and energy, be a catalyst for change in policies and practices, facilitate exchange of information, knowledge and technology, and that is what we are doing precisely now. The 4th one is enable cross-disciplinary and intersectorial engagement. And then very important also, they encourage research and support development of tools to extend innovation into field practices. And then lastly, also to facilitate capacity development. And with each goal, there is, of course, also action plans, and I only will show here goal A, and that is enable higher crop productivity with less water and energy. And you will see strategy A7 is using wastewater or poor quality water for irrigation, but that is then the process of how do we utilize that to the best effect. And part of this webinar is also addressing issues of that. So if we look at African figures, Africa, one of the biggest continents of the world, and there are 54 African countries with each their own climate conditions, and you'll see 1.2 billion people, and it represents about 15% of the world's population. And in terms of renewable resources, it's 9% of the world, or 3,930 cubic kilometer. And due to the fact that the countries, there's so many countries, you'll see there's 60 shared international water basins, with approximately 86% of that water that's been used for agriculture. And irrigation only took place on 42.5 million hectares, so there's a huge potential for expansion. Now, the annual rainfall also varies all over Africa. Congo, most probably the highest, but there's a small almost island place with the called Sao Tome and Principe, which receive about 3,200 millimeters per year, and then a place like Egypt only 51 millimeters per annum. So the total dam capacity, and you'll see the dams as populated there in different colored dots, with the red representing dams with bigger than 60 million cubic meters. The capacity is about 798 cubic kilometers, and it relates to about 53 large dams in 22 river basins. So the webinar today, water management in salt affected area, there's that quotation, and I adjusted it a little bit, but that is a very thoughtful quotation about water and soil, and that say we do not inherit water and soil from our ancestors, but we borrow it from our children. So it's very important how we take care, how we manage our water and soil resources. In soils with a high content of salts, the value and yields are significantly reduced, causing severe socioeconomic and environmental problems in the long run. And the accumulation of salts from improper soil and water management is a serious problem worldwide. And according to the FAO, the global cost of irrigation-induced salinity is equivalent to an estimated $11 billion per annum. So if we look at integrated management of salt-affected soils, we need to stop the loss of arable land due to salt accumulation. Well, to stop it, it is necessary to use appropriate soil and water management practices. And that is what our presenters will, of course, this morning discuss with us. But you can see there's hydraulic principles, there's chemical principles, biological, physical and mechanical ways, and then also some other considerations that one need to take into account and address that. So the objective of the webinar is the understanding of the most important aspects regarding salinity and the role that advanced soil management and irrigation techniques can play in ensuring food security in such areas. And we know the spectrum of agricultural water management is from purely rain-fed to fully irrigated. So you can see field conservation, supplemental irrigation, water harvesting, groundwater irrigation, surface water irrigation, and then very important also drainage. So in the world, there's 1,533 million hectare agricultural lands, of which rain-fed make up the biggest portion of 1,233 million hectares, and irrigated agriculture 300 million hectares. So the 300 million hectares, which represent only 20% of the irrigated of the agricultural land, supplies about 40% of the world's food. So there's a lot of challenges in terms of demand for food, drivers as population increase, and to still sustain food production, we need to increase that by 42% until 2030 and 70% until 2050. And the Food and Agricultural Organizations for the United Nations and the World Water Council predict that the world needs to produce an estimated 60% more food by 2050 to ensure global food security. And it must do so while conserving and enhancing the natural resource base. So you can see the prediction in terms of production levels, where we have to produce more with less. And of course, the success of irrigation is with partners, research companies, producers, and that is where the success lies. So soil health and productivity can be obtained through well-drained soils and effective irrigation. And artificial drainage in agriculture is in practice to improve the natural drainage condition and has been practiced for many years in the world. So 500,000 hectares of the total world's agricultural land are being lost out of production every year due to poor drainage. And you can see the extent of cultivated area worldwide, of course, is the 1,533 million hectares. And there's only about close to 400 million hectares that are said to be provided with sustainable water management systems, mini irrigation or drainage or both. So that is something that we need to address. And you will see the prediction moving forward to 2025 in terms of the changes in terms of crop production output. So different countries with the drained area, that was figures of 2018. You can see the total that is being drained is in a region of only 10%. So in closure, the management of salt-affected soils, many aspects that can be addressed, just to name but a few, is leaching requirements, selecting of salt-tolerant crops, irrigation practices, how we address fertilization, and planting techniques. So it's very important how we take care of our irrigation systems and look after the soils and the water, our natural resources. So we need collaboration between the different parties, the governments, private sector, and civil society. And for joint responses, we have to build on the respective strengths and learn from each other how to manage salt-affected areas, because we do not inherit the earth from our ancestors, but we borrow it from our children. I wish you a successful webinar, and we are looking forward to the presentations that we are about to receive. With that, thank you very much.
Thank you, Mr. President. Thank you, Mr. President, for a very wide overview on the food and agriculture crisis, and then especially the role of Africa in bringing this crisis to a manageable level. Now we have Dr. Jean Boroto, Senior Land and Water Officer from FAO, with his presentation on saline agriculture. Mr. Boroto is a civil engineer with a master's degree in water engineering from South Africa, and where he has worked in water resources management, hydrodynamic and hydrologic modeling, and operational management and planning of state dams in South Africa, where he has been a director of project planning in the Department of Water Affairs and Forestry. He was also regional water expert for Global Water Partnership in South Africa and an international consultant before joining UNFAO as the Senior Water Resources Officer in Regional Office for Africa for 6 years. He manages the Global Framework on Water Scarcity in Agriculture, WASAG, a partnership which is hosted by FAO in Rome since 2017. And now I invite Dr. Boroto to kindly make his presentation.
Thank you very much. Good morning, everyone. I hope you can hear me.
Yeah.
So thank you for the opportunity to speak about the WASAG Working Group on Saline Agriculture. On this first slide, you see 3 logos. The first logo is the logo of the Food and Agriculture Organization, FAO, for which I work. Then on top, you've got the logo of the WASAG, the Global Framework for Water Scarcity in Agriculture. To all the participants, I want you to just write that word WASAG. And then after this webinar, you can go on the internet and Google WASAG. You will see what WASAG is all about and how yourself, through your institution, you can get involved. The second logo is not actually a logo, but it's a symbol of one of the WASAG working groups on saline agriculture, about which I'm going to talk. I'm very pleased to be part of this conversation because WASAG, which is a partnership hosted by the FAO, is managed by ourselves, but it belongs to several partners. Icid, the organizer of this conference, or this webinar rather, are a very active member of WASAG. ICBA, my colleague Sisi, who's going to speak later, ICBA, the International Center for Biosaline Agriculture, they actually lead the working group on saline agriculture of WASAG. Now, why was WASAG established? I hope you can see the second screen. The youth to which I'm talking now, gentlemen and ladies, look, your future is going to be tough. Because if you see on that graph, the way the global world population is increasing and how the water withdrawals are set to increase, knowing that the water resources in the world are limited, realizing that we face climate change. If we go back specifically to Africa, because we are targeting the youth from Africa, Africa is the continent which is expected to experience the highest population growth. And Africa is not spared by climate change. So if you combine the 2 factors together, it means that in 2050, the challenges that we will be facing, I mean, we do face them already. If you think about the droughts that the Western Cape in Southern Africa has gone through, if you think about the recurring droughts or floods actually in Southern Africa, if you think about the Sahel region, which is dry by itself by nature, so you can see that we've got a tough job ahead of us. The food that needs to be produced relies on water resources. And agriculture itself is accountable for 70% of water withdrawals. Yes, in Africa, as we have heard by Mr. The president of Icid, Felix Reinders, the previous speaker, that we have only mobilized 7% of water resources into dams. But the balance needs to be built to make sure that those dams are viable. But if you expose them to climate change, if you expose them to variable rainfall, then you are likely to also build white elephants that will not be able to function according to the conventional science of managing dams. So we need to get our act together, and the youth has got a big role to play in being resourceful. So business as usual is no longer an option, and that's why options of unconventional sources of water, in some parts of the ocean in Southern Africa, we speak about towing icebergs. We speak about demand management to control the losses and waste. But today, we need to speak more closely about silane agriculture. Why silane agriculture? Think about countries such as Cabo Verde, which is a small island, which is surrounded by the sea. The scenario of sea level rise, saline intrusion, all their groundwater is becoming saline. If you think about agriculture and irrigation, you will have that more and more your salinity levels are increasing. So WASAC then came together in order to find a solution to water scarcity in agriculture. We have 68 partners from all over the world. You are unlikely to see your institution there because we have very, very few partners from Africa, and this is an invitation for you guys to join through your institution. Yes, the African Union is a member. We have SARDC in Zimbabwe, but we don't have many. We have got global institutions such as IMI, the Global Water Partnership, and a UN institution, but we don't have many. So this is an opportunity for yourselves to involve your institutions into the global framework for water scarcity in agriculture. So this WASAC was established actually by a meeting of the Minister of Irrigation during the Second World Irrigation Forum organized by Icid in 2016 in October. And then 1 month later, the Director General of the FAO launched it formally at UNCCD, UNCC COP22. That's the United Nations Convention for Climate Change. It was then endorsed by ministers of agriculture in 2017, two big meetings. And partners convened on the 19th of April 2017 in Rome to discuss the need to establish this partnership. And indeed, they accepted. They concurred that it was important to get together. They issued their own statement and they established an interim steering committee. Since then, WASAC has been endorsed by several other events. And the key event that WASAC organized on its own, I mentioned Cabo Verde earlier on. Cabo Verde then, who is a partner of WASAC, offered to host the first international forum of WASAC, which took place last year in March 2019, with close to 300 participants from 40 countries. Process-wise, we have a steering committee that has been elected since 2018. And right now, we are in the process of renewing this steering committee. We just had the nomination for the new members, which close, and the elections will take place from next week. Now, who are our partners? Our partners are made of UN agencies, of government and intergovernmental organizations, academia and research institutions, civil society organizations and NGOs, and private sector organizations and trade associations. For example, Icid belongs to the latter category, whereas ICBA, who's going to present, belongs to the third category of academia and research institutions. So having established the partnership, being hosted by FAO, there was a need to make sure that the partnership is owned by the partners and not by FAO. And there were emerging needs, like low-hanging fruits, that we needed to identify and commit our partners to deliver on them. This is why WASAC then decided to establish 6 working groups. Can you hear me?
Yeah, we can hear you.
Yeah. So we established one group on water and migration, one on drought preparedness, one on financing mechanisms, one on nutrition, one on sustainable agriculture water use, that is really water efficiency. Last but not least, this working group on silane agriculture, which is led by ICBA, as I said, and in which Icid is actively involved. In fact, that's why I'm not really going into the details of silane agriculture, but rather through the process, because my colleagues from this working group are going to give you all the details about it. However, why silane agriculture? First, in the bigger framework of WASAG, when we met in Capo Verde, we agreed on 17 commitments. Those commitments were mostly formulated by our different working groups. And if you see to the right, those colors correspond to the different working groups. Now, commitment number 13 speaks about proposing ways to live with salinity, particularly in small island developing states. If you look on that commitment, it's the sole responsibility of this working group on silane agriculture. The number 14 is about integrating climate smart agriculture and innovative practices, including drought and salt tolerant crops. Again, there are a few groups there, but there are 3. But this working group has got a bigger responsibility to play in this. And I'm happy to report, as you hear from the presentation from our colleagues, that the group, though it was the last to be established, is quite active. So in full words, the first working group, it is said, the first commitment, it says to propose ways to live with salinity, particularly in the most vulnerable areas, including small island developing states. Since it is possible to produce more food from salinized areas, you'll hear that through this webinar. And it includes supporting national strategies and policy for more adaptive farming solutions for salt-affected areas, and the implementation of sustainable salinity farming, including agrobiodiversity to enhance food and nutrition solutions, and cash crops. I mentioned Capo Verde. This working group is supporting Capo Verde. Right now, we are busy formulating a project in order to help Capo Verde cope not only with drought, a drought that has lasted, it's in 4th year now, but also which is resulting in increased salinity, not only in water, but also in its soil. The next commitment is about integrating climate smart agriculture and innovating farming practices, adopting sustainable management practices and proper drought tolerant crops, including in marginal areas to enhance food security and nutrition security. Food and nutrition security. Right now, one of the crops that is very resilient or suitable, it's salt tolerant, is quinoa. I don't know how many of you have heard about quinoa. So WASAG and its partners, ICBA again, and another partner, that's the CIRAD, is a French research institution, and another phase with the Chinese Academy of Agricultural Sciences. We are busy developing 2 quinoa project proposals, and we are targeting several African countries in order to be able to introduce this crop as a way of coping with the salinity challenges. So you might be asking yourself, what is it there for you as the African youth and other participants that are not from Africa? As we said, the world population is increasing. So whatever intervention that we come up with, they have to be people-centered, and we need to focus on vulnerable communities. As you know, very often they are poor, they are not educated, they are no one to look after them, and they live in marginal lands. So we need to bring solutions to them. Our work, specifically in Africa, we need to demonstrate that the science is bringing solutions to people who are challenged by climate change, by increasing salinity, and so forth. Our governments have policies and strategies that still have huge gaps. So we need to come up with policies and strategies that can mainstream silane agriculture, taking into account marginal lands, and bringing into account crops such as quinoa and other crops that can thrive in marginal environments into policies and strategies for food and nutrition security, but also to cope with climate change and for sustainable land management. We have to supplement these strategies, policies with practical tools and guidelines so that we can provide solutions that can be implemented and upscale. We need to build capacity. We need a critical mass of experts. And I hope that at the end of this webinar, some of you will feel compelled to understand more saline agriculture and to get yourself involved and to educate yourself, because this is the science of the future where you can have work to do. You never go without a job and we never go hungry. It is important to pilot this emerging science in other parts of the world, such as in Central Europe, in the Middle East. Saline agriculture is a recurring problem, or it's a way of life. But in Africa, it will become more and more a way of life. I can share with you that, for example, if you have someone from Djibouti in the audience, you know that Djibouti has got problems of salinity. I was facilitating a workshop in Burundi in September. In Burundi also, they recognize that they've got spots of high salinity levels. I was in Senegal in November, they recognized the same. And this problem will be increasing more and more. We need to build resilience, and saline agriculture is a way to build resilience, to cope with climate change, and to deal with land degradation. And if you think about the opportunities that saline agriculture offers, then actually you can address SDG 1 and 2 poverty, SDG 2 food security, SDG 3 on health, SDG 5 youth, 6, 13, 15, and of course everything happens through partnership, which is SDG 17. So with that, Mr. Chair, I would like to thank you for the opportunity to be part of this webinar. And to the participants, our email address is there. If you don't have time to write it, just type WASAG and you'll get all the information, and we are ready to work further with you. Thank you very much.
Thank you, Dr. Boroto, for a very comprehensive view on the WASAG functioning and also the relevance of the working group on saline agriculture. Now we will have the presentation from Dr. Marco Arcieri, Vice President ICID, on water resources management in salt affected areas. Dr. Marco is presently the Secretary General of Italian National Committee on Irrigation and Drainage, and he has a professional career which is spanning more than 20 years. He has contributed in various studies and research in agriculture, water management, land and water resources development, irrigation and drainage, flood prevention, drought monitoring, forecasting and mitigation, a very comprehensive area of water resources management. And he has a wide expertise, and he has visited around 40 countries in order to implement international research projects and attended advanced professional specialization courses. He is also serving as a technical researcher in Italian Ministry of Agriculture, and is conducting several surveys in Italy and abroad. And he is a member of ICID since 2008 and was elected as Vice President of ICID in 2011. He is also a member of ICID Working Group on Water and Crop and History, and he has been also appointed as a permanent observer to UN agencies FAO and IFAD. He is a very active member of our ICID community, and he has a lot of knowledge to share on the agricultural water management. And I will request Dr. Marco Arcieri to make his presentation, please.
Thank you, Secretary General. Can you see my screen, my presentation?
Yes.
Okay, very good. So I will start my presentation now. And first of all, let me thank you, of course, ICID, for this opportunity to give this presentation, to join the Young Professional Forum of Africa. And it's a pleasure to be today with all of you and to share some of the consideration that this webinar is dealing with. I will be talking today about giving some hints, some indication on how to manage water resources in salt-affected areas. So what is the situation now for the distribution of the global fresh water in the world? As you can see from this interesting data, the distribution of global fresh water is only 2.5% of the global water on Earth. So we only have 2.5% global fresh water, and of these, only 0.3% up to date is the proportion of the world's fresh water that can be considered as renewable. So, as Mr. Boroto was saying, the situation is currently really very endangering, very serious, and the perspective is really serious. And it has to be considered very seriously. That's why WASAG decided to establish this working group also on saline agriculture. This is a map to show the most important salt-affected areas in the world. So as you can see, we could say it's quite a worldwide spread problem. And here are some figures to show some of the salt-affected soils, especially in drylands, divided by continents, as of UNEP 1992 and more recently FAO Global Soil Partnership data 2015. So as you can see, Australia and Asia together are almost a third, more than a third of the global salt-affected areas. Africa, of course, in terms of million hectares, is almost 210 million hectares. But of course, the problem is also in Central Asia, North Asia, as you can see here, and in South America as well. So globally, the figures tell us that it's more than 1 billion million hectares of salt-affected areas in the world as of now. Now, what is the approach when discussing, when considering how to manage water resources and irrigation under saline conditions? Actually, we could say that usually there is not a single methodology we could consider in managing salinity, especially on irrigated lands. So what we should do is to adopt an integrated approach. This means, as also in his presentation, in his remarks, opening remarks, President Reinders was indicating, we have to consider, when we're talking about water resources management, we have to consider aspects regarding leaching. That means the requirement, the frequency, the drainage, of course, which is very important. That means we have to consider the appropriate system of drainage, the depth. We have to consider the depth where the drains have to be put according to various different soil conditions, and the spacing, of course, of the drains. Dealing with irrigation, we have to consider the most appropriate system or technique of irrigation, the water irrigation scheduling. And another important aspect is to consider regarding the multiple water resources used. That means alternating water resources of different qualities or blending quality of different water resources. Now, leaching requirements. A good leaching requirement estimate, of course, is important because it can result in more effective water use, especially in the beginning, in the first instance, as it determines a reduction in the salt load which is needed to dispose of. And of course, it also can guarantee a substantial and significant reduction in the volume of drainage water. So this is why it is very important to assess most precisely possible the correct leaching requirement in order to dispose of the salts. Now, when the leaching requirement is met, as you can see here from this figure, of course, the accumulation rate of the salts in the soil stops. So there is no further accumulation of salt. This is why assessing leaching requirement is very important, because the salt content, we could say, it tends to remain constant over the long period, over the long term. This is why leaching requirement assessment is very, very important. And of course, experience is so much important on this aspect. Of course, as I was saying just a few seconds ago, it's not very easy to assess, because the drainage rate, as we all know, is rather more a function of the characteristics of the soil rather than of the water content of the soil. Now, I very quickly, as I was saying before, another important aspect we have to consider when we are dealing generally with water resource management, of course, is the system of drainage. We have to take into account the depth of the drains we have to place and the spacing. There are some formulas that can help us in determining the correct depth, the drain spacing, of course, according to the hydraulic conductivity of different soils. So this is why it is very important to have a proper drainage system and technique. Coming to irrigation, what we can say about how to deal with irrigation when we are working, when we are conducting agriculture on saline soils. Of course, most important is the appropriate choice of the irrigation system, and a correct proper management of the water irrigation scheduling can also be very helpful. Of course, drip irrigation. Drip irrigation is probably the most appropriate system we could think of, because when dealing with salt-affected areas or saline waters, because it can provide the best conditions for the soil water protection, because it can avoid, of course, also leaf injuries, and it can prevent the salt accumulation on the wetting front. But of course, it has also some other aspects. Now, the frequency rate of irrigation when we are dealing with drip irrigation is very important, because it can affect soil moisture salinity distribution in the profile, as well as it can also affect the anti-clogging performance of the drip irrigation system, which is a very serious problem, of course, as you all know, because it can change the falling growth inside the emitters. Some limitation, of course, with this particular system lie in we know that the drip irrigation system have a high initial cost, can create low root soil conditions for aeration, creates dense root mass. So not every crop, of course, is suitable for this kind of irrigation system. There is a constant need of power and water supply. So this is very important. These are very important aspects to be considered. And besides, it requires also a very high level of know-how in order to properly manage this system. Another system that can be used in some areas, it is used when dealing with saline waters, is the sprinkler irrigation. Now, the main problem, of course, with this system is that when we are using saline water, the wetting and, of course, the possible burning of the foliage is very likely to occur. So we have to consider, when we are considering using this kind of irrigation system, we have to have a very clear mind, very clear idea about the crops we want to use with this irrigation system. Of course, the salt removal efficiency tends to be higher than when compared with systems such as flooding or trickle irrigation. Now, subsurface irrigation can be efficient in salt-affected areas, but the problem is that this particular system provides no means of leaching the soil above the surface, above the soil. So unless the soil can be leached by the appropriate pattern of rainfall or by surface irrigation, the problem with this system is that the salt levels almost certainly will become high and toxic for the plants. So we could say that this system is not really suitable over the long term, especially when salinity values are very high, also in the water supply. I want to share with you an interesting approach that I have been coming through just in the past months is an innovative way of accomplishing salt percolation by sending a very low level electromagnetic signal through irrigation water. This is provided by a system, electromagnetic system, and so this electromagnetic signal is sent to the irrigation water before this water is applied to the crops. So what happens that these electromagnetic signals can really change the organization and of the molecules of water and the behavior, of course, of the minerals, so that the plants, as you can see in this figure, really can absorb the exact amount they need. So with this system, as you can see, the salts are, because of this change in the structure of the molecules, the salts can be effectively dissolved and they can be transported down below the root zone. So for those who are interested in this innovative approach, you can find some references here on this paper, but there are so many others you can go through about this innovative approach. Of course, this is just to show the importance of a correct and proper scientifically based irrigation scheduling approach. Now, as I was saying before, an important aspect is also when we are conducting agriculture in salt-affected areas is the option of having multiple water resources. As you can see in this photo, you can, this is a technique which is called recycling or alternating technique. This means that you can use either once good quality water and the next time you can use poor quality water, or you can have the so-called network dilution, which you can blend different water resources of different qualities. This is another approach which is used in can be used in salt-affected areas. Now, coming to another interesting approach is the solar-powered water pumping and desalination, which has been dealt with in Capo Verde. This is a real interesting example of Mr. Jean Boroto in his nice presentation, in his interesting presentation regarding the activities of WASAC, was talking about Capo Verde, where we were we have been holding the first international forum on water scarcity and on behalf of FAO and WASAC. So this is a very interesting example of what can be done in water scarce areas. So with this technique, there has been a pilot desalination system that has been installed in Capo Verde in order to pump and distribute fresh water. And really, this is an excellent example of how it is effectively possible to create conditions for sustainable development of agriculture in areas which are affected by water scarcity. So how the system works, you can see here, of course, it is powered by high efficiency solar panels. These solar panels have these characteristics that not only they intercept direct solar radiation, but they can also intercept the amount of radiation which is reflected by the ground, adding another 40% of energy that can be stored and used and converted for this system. So this is a very simple example of how a water pumping station solar powered is working. So this pumps works about any distance and altitude, 100% powered by solar energy. Interesting thing is that the capacity of this kind of system is about 10,000 cubic meters per day. It is autonomous, very low maintenance cost, doesn't need any battery. It can be remotely monitored and managed, and it can guarantee over 30 years of lifespan. The cost of the water produced is really very low, as you can see here. After OPEX is 0.02 to 0.03 euros per cubic meter of fresh water which is pumped by this system. Which leads us to the solar power desalination system, always which is also being dealt with in Capo Verde, as you can see here in this figure, in this graph. It can desalinate any type of water, brackish and seawater as well. It is 100% powered by high efficiency solar panels. The capacity in this case is a little bit lower. It's about 1,000 cubic meters per day. But of course, it can be increased by means of support of other power sources. So a single system can elaborate up to 1,000 cubic meters per day. It always operates autonomously, doesn't need any battery, over 30 years of lifespan, very low maintenance cost, which is very important, especially for water scarce areas. It can be remotely monitored and managed. And finally, which is most important, the fresh water produced has also very low cost after OPEX, and it can be ranging according to the dimension and to the quantity of water, the amount of water that is treated, ranging from 0.2 to 0.5 euros per cubic meters. I hope that I would like to show now a video of this system that has been installed in Capo Verde, just to let you see what is the final result. I hope it's going to work.
Video just डॉक्टर को रगब इंट्रोड्यूस करके आप ये बोल दीजिए डॉक्टर जैन को अपने चैट मैसेज भी देखने की बोलना पड़ेगा webcam there also.
I think video is running in a very, yeah.
Yes, I don't know if you were able to see, but that was just to have an idea of how it is really possible to have irrigated agriculture in very severely affected water scarcity areas like Capo Verde. So with this, I thank you all, and I leave the floor to you, Secretary General. Thank you.
Yeah. We will put this video on YouTube so that this part, which may not have been seen by many because of the bandwidth limitations, you will be able to see it there. So thank you, Dr. Marco, for a very presentation and a very learned presentation on the various techniques required for managing saline agriculture. Now we have Dr. Ragab, Vice President Honorary at Icid, on the management of saline and brackish water for irrigation of conventional and non-conventional crops. Dr. Ragab, he has a BSc in Soil and Water Sciences, MSc in Irrigation, and a PhD in Rural Engineering, University of Leuven, Belgium. He was the chairman of UK National Committee on Irrigation and Drainage, and presently he is a fellow at UK Centre of Ecology and Hydrology, Oxfordshire, UK. He is also a chairman of our various working groups like poor quality water, crop, and drought, etc. And he has more than 40 years of experience in irrigation, drainage, hydrology, remote sensing applications in hydrology, irrigated water management, the climate change impact on water sources, soil water plant atmosphere relations, rainfall harvesting, use of poor quality water for crop action, organic farming, etc. He is associated with many professional organizations, which include the soil science societies from British, American societies of the similar nature, and European soil science societies, etc. So I would request Dr. Ragab to make his presentation, please.
Thank you, Secretary General. Good day to everyone, wherever you are. As my colleague Marco mentioned, we don't really have much fresh water. Fresh water represents almost like 1% or less than 1%, and most of that water actually in the ground, and some of it actually, or half of it, is brackish water. The salinity has really negative impact, and that's why we have to manage it carefully. Toxicity of certain ions like boron, nutritional imbalance, and also reduced growth, yield, and transpiration. The water is classified worldwide to non-saline, to brine water. Non-saline would be less than 0.7 decimals per meter, to high saline 10 to 25, brine, which is like a seawater salinity greater than 45 decimals per meter. The management practices for saline water involves irrigation, water management, crop and soil management, accurate estimation of the crop water requirements, management of waters with different salinities. And also it requires selection of crops or crop varieties that produces satisfactory yields, irrigation method that would maintain a relative high level of soil moisture, because keeping high level of soil moisture would allow actually the plant to be able to tolerate even higher salinity. In terms of water management, irrigation system and its efficiency is important. The strategies, which the way that you put the water to the plant is also important. The quality of waters and how you add it by mixing or salinating or cycling. Leaching is also another important aspect in the management. The drainage water and the controlling of the water table is quite important in the management. Drip irrigation, especially the subsurface, from my experience, might be different from Marco, is the best suited drip irrigation for the moment. And we got actually good results from using the subsurface drip irrigation compared to the surface. And I will show you some slides. Seasonal leaching is required when you use that irrigation system. Sprinkler can cause leaf burn in sensitive crops, it's not recommended. Furrow planting location is important, but also could be managed properly, or could be managed not properly, and that's what you see as accumulation of salts when you use basin irrigation or drip irrigation that's not managed properly. Now, sprinkler irrigation would actually allow the salt to fall on the leaves of the plant and actually burn some of the sensitive plants to salinity. However, there are now center pivot systems with low nozzles closer to the surface, soil surface, that would actually maybe prevent salt accumulation on the leaves, and that would be a better alternative than the overhead sprinkler irrigation. And this is the difference between surface drip and subsurface drip. You can see the wetted areas on the surface. If that's irrigated by saline soil, that would turn into a white, actually white salt, and could cause crust. And while in the subsurface, you don't see that wetted area on the surface. At the same time, the subsurface irrigation would keep the soil moisture high in the root zone compared to the surface irrigation. And keeping the soil moisture high in the subsurface would actually allow the plant to tolerate higher salinity because of the dilution due to the high soil moisture in the root zone. This is the classical drip irrigation system, but you don't really have to go for that if you don't have the resources. There are low-tech, low-cost drip irrigation system used all over the globe, and in Africa in particular, there is a lot of that sort of system that's affordable to smallholds. Now we actually tried something else, tried to irrigate half of the root zone with saline water. And this is, they call it partial root drying method, where you have on the right side that the normal drip irrigation, where you actually have the drippers, they irrigate the whole root zone, while in the one in the middle and the left would actually allow you to irrigate only one vertical half of the root zone by one drip line, and the other drip line would actually irrigate the next time. So you alternate two drip lines. One would irrigate one day, and the other one would irrigate the other day. So at any time, you only use one of the twin drip lines to be operational. And actually, we found this saves a lot of water for irrigation. And we have the subsurface irrigation, what we used was under the surface by 10 to 12 centimeter. And as you see, the plant is in the middle between twin lines, and those twin lines, they irrigate in alternating way. And actually, we found that we used the saline water in that system, and it did work without any problem at all. And we managed to grow potato and tomato and maize, 3 crops with that system. The salinity that we measure in the field, actually, I should report that is different from what people they measure in the lab. The saturated paste extract salinity is quite different. The soil salinity in the field is associated with soil moisture of that spot at that time, and it is different from really what you measure in the lab. And a lot of people, they try to verify models and test models by using the laboratory salinity and comparing it with model salinity, which that's a big mistake. And we are using different, of course, instruments to measure the salinity and to measure soil moisture. Here we started by the normal way, the soil cores, and then the neutron probe and the profile probe, and the ERT, electroresistivity tomography system, and then we ended up by using the Cosmos for soil moisture measurements. And here you have these sensors nowadays where you could use to measure both the soil moisture and the salinity, and that's actually the way forward, rather than to take samples to do salinity in the lab. And it can give you a continuous measurements of soil salinity. And this is example here for the partial root drying method PRD, the right drip line, and also the left drip line, and also you can have the blue line that represents the normal regulated drip irrigation system. So you can have continuous measurements giving you an idea about what's happening to the salinity. The ERT, or electric resistivity tomography, and that's actually transects. We use it over the field, and those electrodes, we push them in the ground, and we measure the soil moisture and also the uniformity of the irrigation system. And also we can use the system to figure out the salinity distribution across the field. The new system now we are using is Cosmos, which is area-based soil moisture contents in the soil. Now, the strategies of using water of different qualities, as my colleague Marco mentioned, you have the network dilution, where you have two channels coming together with different water qualities, and then you have a third one with the mixed water, and then you use that for irrigation. Otherwise, a soil dilution, with you alternate, you irrigate with saline water followed by fresh water. So you dilute the salt in the soil. That's why you call it soil dilution. And also you can have cyclic management. And this is here what we used in one of the experiments in Egypt, where you have the two tanks here as well on small holdings, where you can have one for saline, one for fresh, and one for mixing, and then you apply that to the drip system. And this is another system we use in Napoli. And also you can have here the two big reservoirs with fresh and saline water, and we mix them and we use that mixer. And another way, of course, of applying the saline water is by sequential. So you apply the water to one field, you take the water from the drainage of that field, you irrigate the next field, which has usually more salt-tolerant crops, and then you pass it on to the next field. As you see here in that picture, start by salt-sensitive crops first, you irrigate with saline water, collect it from the drain, add it to more salt-tolerant crop, and then you collect that from the drain, irrigate another salt-tolerant, and so on. This is the sequential application. Leaching is quite important, and I always insist that we shouldn't use leaching unless really it exceeds the plant tolerance limit. Otherwise, it will actually be a wasted resource of water. So it can be done by the unavoidable irrigation efficiency, especially related to surface irrigation, occasional rain, and apply seasonal, which we recommend, but we don't really recommend after each irrigation because that's unnecessary to leach the fertilizers as well as the salt. And the crop management would actually also require a selection of tolerant crops, suitable varieties, and also to apply low salinity at the most sensitive growth stage and higher salinity at other stages. And this is just, I will show you that for semi or tolerant crops, we look at the crop stage and we apply the fresh water at the stage where the plant is sensitive to water, like sowing and seedlings, and then we apply the saline water in the vegetative development, and then we apply the fresh water when the plant is sensitive to salinity, and we apply a leaching requirement if required for that. And we can see the salinity build up during that period, of course, when you apply the salinity at some stage, and you will need to do a bit of leaching at the end. When you have a sensitive crop, and this is actually requires fresh water almost all the way, and if the soil is saline, you might also need to have initial leaching before the sowing and after the harvest. And the salinity, of course, of that soil will be going down when you irrigate with fresh water. Most of the plants actually are classified into sensitive, moderate, sensitive, and so on. So it depends on the water, really salinity that you have. You can actually select the crops that you suitable for that salinity of water. This is an example of a chickpea. We have been in a project together with Icarda in Syria, and here chickpea fresh water 100% and saline water 100%, and actually the yield was comparable. Here we in SaltMed project, we also were able to use saline drainage water in Egypt to grow tomatoes, and also we managed to grow cherry tomatoes in Malaga in Spain by also using saline water. And we found the sugar content of the tomato irrigated by saline soil was actually more than the sugar content of the tomato irrigated with fresh water. Also, we actually discovered that the relation between the salinity and the yield is not linear, as Maas-Hoffman equation that everyone is using suggested. And this is just an example of a recent work for lentils, chickpea, and faba bean, but the equations, linear equations relating yield and salinity, it was maybe good for the 60s. They are not good for the time being, really. These examples from ICBA, actually, my colleague now will mention more about it, where the barley can grow with salinity water up to 15 decimens, and also pale millet can grow in the range from 5 to 15 decimens per meter. Also, another nice slide from the work that ICBA is doing on halophytes and also fodder, using also highly saline water. This is saline water used on non-conventional salt-tolerant crops like quinoa. You know, of course, FAO had 2013, the year of quinoa, and we have been actually using this quinoa, which is a cereal crop, started in Peru in Latin America, and we have tried that actually in several countries. A project funded by the EU, quinoa and amaranth as two crops. And this is really the quinoa we grew with saline water in Turkey, example in Napoli area, and you can see the mixing reservoirs, fresh and saline water. And also here you have example from Morocco, where also we use the quinoa. And also the quinoa now is grown in the UK. And we have here a young agronomist started the business a few years ago, and now he is the main supplier of quinoa across the UK. And if you look at these results, what we got from this project, you can find that in Denmark experiment, the quinoa was irrigated by 40 decimens per meter, and we got a relative yield of almost 70% of the one that irrigated was fresh water. And in Italy, we managed to get 97% relative yield when irrigating is with 22 decimens per meter. It's a very promising, as Jan just mentioned earlier. The land management actually for using saline water, it's also you need uniform distribution. You need to encourage the filtration, better salinity control, subsoiling, chiseling, and plowing, and break the compaction and pervious layers, and also treatments like plowing, adding mixing sands or gypsum, organic matter as amendments. Now, accurate estimation of crop water requirement, especially when you irrigate with saline water, is important. Why it's important? Because accurate estimation of crop water requirements, it means that if you add more saline water, you add more salts and more leaching of nutrients and fertilizers, and decreasing the soil and groundwater qualities, and increasing water productivity and decreasing the water productivity and water use efficiency, and also you irrigate less area. And from the recent work, which I presented somewhere else, that we found the crop water requirements based on the equations of FAO or any Pliny-Cradle, Hargreaves, and so on. They give you a potential evapotranspiration, and that's people they consider it, if they multiply by the KC, is the crop water requirements. My experience is that this actually overestimates the crop water requirements. When we use scintillometer and ecovariance and Cosmos as new instruments to measure the crop water requirements, we found actually the crop water requirements measured as actual evapotranspiration was almost half of what you calculate from the equations. So by this, actually, we are wasting half of the water resources by only relying on equations based on meteorological parameters. Another thing important also for field scale is to use the models, because the salinity is a slow process, and most of the crops, they grow in a few months as a season, and that slow process of salinity buildup requires calibrated, validated model to predict the salinity over a longer period, so you can plan properly your water management. We developed a model, and it's called SaltMed model, to deal particularly with salinity, and that's available from the Icid website. If you go to Icid website, you can free download the SaltMed model. And also there is a course of that model running in my organization at Center for Ecology and Hydrology. You can go to the website, and if you would like to register to the course, but at the same time, I give several trainings to young African professionals in different countries, South Korea and Cairo, and different countries as well. And what the model can give you this example of drip irrigation, the soil moisture distribution, the soil salinity, and if you have multiple drip irrigation, you can see the soil moisture salinity development under each drip, and also gives you the dry matter and yield in addition to so many other parameters. So that model actually can also be used to obtain some other missing parameters you cannot collect in the field, like KC, like a KCB, like Pi 50, like the prediction of the CO2 impact on the yield, and also can help you to design your experimental field trials much better. Can also help you to design a program for data collection, and also to estimate the crop water requirements and the schedule. And of course, the importance of really management of saline water is to avoid what actually was seen here on that slide, which is accumulation of salts in the soil profile. With that, I thank you very much. Thank you.
Thank you, Dr. Ragab. It was a very comprehensive presentation covering a very large range of technologies and approaches for managing the saline agriculture. Now we have Dr. Dionysia Angeliki Lyra, Helophyte Agronomist, International Center for Biosaline Agriculture, on speaking on saline farming, a tangible reality for sustainable food production in salinized areas. Dr. Lyra works as a Helophyte agronomist at the International Center for Biosaline Agriculture in Dubai. She has been working on evaluating helophytic germplasm in inland and coastal desert areas, exploring multiple uses. She is also working on modular farming systems that integrate agriculture with aquaculture, utilizing low quality water resources such as the reject brine from desalination to grow helophytes. And she has also won a live program for the grant for the project Inland and Coastal Modular Farms for Climate Change Adaptation in Desert Environments. She is currently working with national and international partners to scale up helophytes in farming areas in UAE and Egypt to create helophytic based food and feed products. Our vision is to develop, through successful partnerships, integrated farming systems tailor-made to the needs of farming communities living in sanitized areas, utilizing low quality water and land resources to grow helophytic crops, enhancing food nutrition, water and income security. So I would request Dr. Lyra to start her presentation.
Okay, thank you, Dr. Ashwin. First of all, can you hear me? Can you see the presentation?
Yes.
Okay. So first of all, I would like to thank Icid team and specifically Marco for the invitation and for my participation in this exciting webinar with so many other esteemed panelists. So I would really like to thank you about this. So yeah, let's move on. So the first slide, we can see a global salinity map that actually shows the extent of the salinity in all over the world. And actually, based on another webinar that took place, was organized by FAO WASAG team, there was this kind of announcement that the Global Soil Partnership team are in the process of developing, and they're going to have a new global salinity map by the end of this year, showing even higher and bigger extent of the salinity issues on global level. So Here represents some countries that are really devastated by salinity, and they have millions of hectares of salinized areas. And apart from the soil salinization, we have also to highlight the increase of the salinity in the groundwater reservoirs. For example, in MENA region, over 30% of the groundwater resources are saline, and specifically in the GCC region, 70% of the groundwater is already saline. So in these regions where the water scarcity is a big issue, the salination could be considered as one way direction to produce fresh water for drinking purposes and, of course, for agriculture too. We have to consider that the salination technologies are becoming more cost-effective and more energy-effective, although the management of the reject brine is still an issue to be sorted out. So in this slide, we can see that on global level, what is the production of the reject brine worldwide. And actually 70% of this reject brine production of this byproduct is actually produced in the MENA region, in Middle East and North Africa region. So the resources that we have in our hands to utilize for the saline agriculture implementation is actually these saline water resources, whatever these are. So we have the brackish groundwater, the seawater, the reject brine from desalination, drainage water, even the water that is utilized for aquaculture farming, for aquaculture production. Also, we have in our hands these degraded soils. We have saline sodic barren areas, like, for example, in desert area, in desert environment, we have sandy soils to consider for agricultural production. And of course, we have two different plant groups that could be further investigated to be incorporated in a saline farming system. So exactly this graph shows that as the salinity increases, some crops, the biomass of some crops really decreases. But however, there are still some crops that can really thrive under very high saline conditions. So we have exactly these two groups. For example, Dr. Ragab previously in his presentation mentioned barley. So barley actually in the group of the conventional crops is the plant, is the crop that has the highest salinity tolerance compared to others. So in this group of conventional crops, we can identify, we can develop salt-tolerant varieties that could be irrigated with water, with saline water up to a certain limit. Beyond this limit, there is another group, plant group, that we call it halophytes, or plants that can really thrive in saline conditions, like salt-loving plants, that can really be used for different kinds of purposes, for food, feed, biofuel, and for other industrial uses too. And these are the so-called and well-known halophytes. So why saline agriculture is proposed for salinized areas? Exactly because these saline farming systems, they release pressure on good quality water and land resources. And of course, this is the reason that for the implementation of saline farming systems, we are utilizing this low quality, poor quality of water and soil. Also, we can have different kinds of uses out of the products, food, feed, fiber. In addition, we can generate employment opportunities for the communities that are living in these marginal and saline areas, and specifically, we can give leverage to youth and women who are actually living in such deprived zones. And of course, saline farming systems can be incorporated as a kind of solutions for climate change mitigation and adaptation projects. So In the following slides, I'm going to show you some of the I'm going to highlight some of the ICBAS projects, which are really giving tangible results in terms of productivity, in terms of economic profitability for the farming communities. And of course, for more information, you can ICBAS website to look for more information and to collect more data about some projects that are ongoing or have been completed. So I will start with a project that took place in United Arab Emirates. The target here is how we could rehabilitate degraded lands. And actually, you see that some farms in UAE, they were abandoned exactly because of the high salinity of the irrigation water. And we introduced these 4 salt-tolerant perennial grasses like Distachylus spicata, Sporobolus, Paspalum. And actually, the biomass, the production out of these highly salt-tolerant grasses was really high and very much higher compared to Rhodes grass, which cannot tolerate that high salinity, and also it's very water-consuming halophytic grass. I'm talking about Rhodes grass. So overall, we observed that 44% less water was used than the traditional forages. This is another project that takes place in 7 countries. So the project is focusing on introducing salt-tolerant crops, and of course, this is accompanied by the best agronomic management packages. And in addition, it's not only how we are going to grow the crop per se. We also have to focus on how we can develop the whole value chain from the field till the halophytic product reaches the market, reaches the shelf, or reaches the customer, the consumer. And of course, always in such saline farming systems, we have to consider that it's really important to develop tailor-made, customized, also in their local languages, capacity building programs and training packages for farmers, for farm workers, and extension officers in the countries where such projects are implemented. The third project that I'm going to talk about is called the RAMSAP project. Is funded by IFAD organization. So actually, the target, the scope, the aim of this project is to rehabilitate degraded lands in Ethiopia. Ethiopia is estimated that it has around 11 million hectares of lands which are really under the threat of salinity. So this project is actually targeting to incorporate, to introduce, you see different kind of crops here, like barley, sorghum, quinoa, cowpeas, spania, pearl millet, Rhodes grass, panicum, and cenchrus that can really tolerate different kind of salinity levels in 5 regions in Ethiopia. And actually, the current results show that these crop varieties, these salt-tolerant varieties and these halophytic crops can produce 20 to 30% higher yields than the local existing varieties that the local communities are growing. The fourth project is related to quinoa. It's, of course, from the previous speakers, quinoa was mentioned as one of the crops that can really tolerate high salinity levels. Of course, quinoa is considered a superfood. I'm sure most of our participants, of our audience here, they know about quinoa, even they have tasted quinoa. So quinoa is a superfood. It has a high protein content, and also compared to other staple crops, it has high calcium, iron, magnesium content. ICBA has developed 5 salt-tolerant varieties that are currently tested in Morocco, and you can see the different kind of seed yield values achieved, and also in Egypt. As I mentioned, it's not only that we are focusing on the crop cultivation, on the proper management practices and the proper cultivation of quinoa. We have to develop the products that incorporate quinoa as ingredient, or also to convince the local communities to integrate in their local kitchens, in their local cuisines, in their local dishes. This is why chefs and business developers, whoever is related to the market sector, different kinds of stakeholders are needed in order to create this market segment, the market demand, so that this different kind of quinoa or any other halophytic crop to really have high demand and high market value in the end. This is another project that we are funded by HSBC Bank, and it has three components, two of which are implemented in Egypt, and one is implemented in the United Arab Emirates. So, as I mentioned, quinoa, we are evaluating, and we are, sorry, I'm going to drink water. So, as I mentioned, we are also introducing quinoa in Egypt, in a new valley actually in Egypt, where there is abundant saline groundwater resources. So it's not only that we're also targeting, the proper quinoa cultivation, it's also how we are going to leverage and give add value to the quinoa crop by giving emphasis to other value chain components too. In addition, for the very first time at the Red Sea Governorate in Egypt, in Shalatin and in Marsa Alam, we have, for the very first time, we're evaluating different Salicornia genotypes developed at Tikba. And the focus for the time being is for Salicornia to be used as forage. And at a later stage, we will see, based on the first observations and findings and outcomes, to continue for food products. The third component that takes place in the United Arab Emirates is about developing training packages on integrated farming, where different kind of videos are developed on different thematics. And these videos are translated in Urdu, Arabic, because actually what we are targeting is to reach the farm workers. So these training videos are going to be uploaded on smart applications, because actually smartphones are becoming more and more popular nowadays, even on farm workers level. So it would be good for them to have immediate access to such kind of training material, for them to be utilized on the spot as a kind of hands-on training experience on the spot, without having the trainer in person whenever the trainer is needed. So you see here that, for example, for quinoa, we run currently several quinoa trials in New Valley, and on the right you can see different kind of products, and on the right you can see also some Salicornia field trials, where different kind of Salicornia genotypes have been introduced. The sixth project that I'm going to refer to is the inland integrated aquaculture farming system that has been developed at ICBA. We have been working on such kind of integrated farming model since 2014. So the concept here is actually how we can utilize the reject brine from desalination, since approximately 15% of the farmers in the region, they are installing desalination, small-scale reverse osmosis units to desalinate the saline groundwater. So the fresh water, the desalinated water is produced to grow vegetables, either in the open field or in the net house, greenhouse, and then the reject brine is directed to grow fish, and the water from the fish, which is rich in nutrients, is utilized to grow halophytic forages and salicornia. Salicornia is a multi-purpose crop. It can be used as food, as either pickled or fresh, also as feed and for other for biofuel. So it has a multiple spectrum of uses. And this type of integrated aquaculture farm, this model has been introduced in 8 farms in UAE. So we are working for this project. It's a big team. We have different kind of partners, governmental partners, research institutions. We have our fish expert and nutritional expert too. And the objective exactly is how we can add value to the reject brine to grow tilapia and salicornia. Also, we are partnering with a company here in UAE, Global Food Industries, to create halophyte-based products. So you can see some of the dishes. We have also chefs partnering with us to develop different kind of dishes. This is also another activity under this project. It's called the Halophytic Kitchen Lab program, where actually our goal is to raise public awareness of the audience, of the people, of the public on halophytes. So we have a chef on board and we have a nutritionist. So we are going to run interactive live cooking sessions. Actually, the plan is to invite students as soon as, of course, the social distancing measures are lifted and things are much more safer. So this kind of activity is going to be run hopefully from October onwards. So we're going to have also a nutritionist on board to discuss and inform the audience about the nutritional qualities and properties of the halophytic crops. So these are some of the products that I mentioned, which have been developed by the global food industry. So you can see different kind of versions that actually salicornia can be utilized as ingredient. For example, the burger, the smoothie, biscuit, cheesecake, even using local products, because the goal, the vision here is how we can create a halophyte-based industry, food industry, or even feed industry in a desert environment that could be replicated in similar climatic context regions. So the conclusions coming to this part. So what I wanted to show here is that it's not only the crop. We can really have tangible products. So by having the whole value chain here from A to Z, it shows that saline agriculture has huge potential in salinized areas. Now, how this can be realized? This can be realized through a multidisciplinary approach in terms of expertise and technologies. We have to bring together the soil expert, the irrigation expert, the agronomists, the extension officers, the farmers, the farm workers. We have to bring also these in layman terms for the people to understand and how to apply the different kind of management practices. And now we come to the third very important factor, which is actually the capacity building of farmers, farm workers, and extension officers. For us, for ICBA, and personally for me, since I'm leading such projects, is vital, because this guarantees the sustainability of saline farming in salinized areas. And of course, what I also wanted to show is that halophytic products can really have value, can really have market value. So such kind of products, and of course similar related industries, are feasible to be realized in such a marginality context, in such salinity context. So my quote, let's say, is that saline agriculture goes beyond nice stories to show in very informative webinars, in very nice conferences, in very nice workshops. It can be, and of course it is, a tangible reality in salinized areas. So for more information about the projects, and of course, if you want, as Jean mentioned, a member of the Saline Agriculture Working Group, please visit our the web pages, and we are more than happy to have you on board and brainstorm about different activities that our working group is running, and also about what ICBA projects are related to and which countries also can be implemented. And with this, I would like to thank you for attending this webinar and also for the invitation. Thank you so much.
Thank you. Thank you, Dr. Lyra, for giving a comprehensive presentation on techniques that are being used for the saline agriculture promotion in various parts of North Africa and the Middle East. It's a very valuable approach for the arid and semi-arid areas that are there in this region and maybe the world over. So now this brings us to the end of the presentations from our panelists, and we have some small time available for audience discussions. So if any, yeah. Before we go for the audience discussion, we can we have the brief by Dr. Wahba, Vice President Honorary Icid, on the activities of African YP groups and various other areas. So I request Dr. Wahba to please discuss, share these issues.
Dr. Wahba, you can share your presentation, please.
Till we are able to sort out the audio problem with Dr. Wahba, we can go ahead with the questions and answers for the audience. So audience, if anybody is interested in asking a question, I would request him to raise his hand so that we can give the rights for speaking. And preferably, if you want, you can also type out your questions in the chat box so that we are able to have them all, and then we can answer them.
Actually, we have received one question from Mr. Millicent. He's asking, what are the impact of saline agriculture in surface water? So if any of the panelists will like to answer his question, like Dr. Ragab or Dr. Jean Boroto, he's asking, what are the impacts of saline agriculture in surface water?
Hello.
Dr. Ragab, will you like to answer this question?
Yeah, that's good.
What's the question again?
The question is, what are the impacts of saline agriculture in surface water?
In the last two words?
Surface water.
Surface water.
So the effect of using saline water on the surface water, is that the question?
Yeah, saline agriculture on surface water.
And the surface water.
Yeah.
So basically what my understanding is, you are talking about if saline agriculture would affect the river water quality.
It may be because he has written only this one. What is the impact of saline agriculture? So basically, it may be on quality or some other aspect.
Well, the saline agriculture can affect the water quality in the rivers and freshwater streams. It's because of the leach of the salt that goes to the drains, and the drains most of the time, actually, they are connected to irrigation canals and to the rivers. There are some rivers in the world, including the Nile. In some parts, they are actually irrigation water, and in some parts they act like a drainage for surrounding areas. So saline agriculture would affect, if it's not managed properly, when leaching frequently the salt will find its way to the surface water. That's in areas where you have surface water and rivers nearby. In areas where you don't have surface water and you have brackish groundwater, if you use so much water by excessive leaching, that salt will find its way to the aquifer. So that's why we are careful with the leaching requirements, and a lot of people, they add automatically to the irrigation requirement a certain percentage for leaching. And if you are irrigating with saline water and you add 15% leaching of the same saline water, you are adding 15% extra salt. And that extra salt will find its way either to the groundwater or to the surface water. So that's why it's the issue of leaching requirement is misused and abused by so many people who lack the experience on the environmental issues. So usually we sorry.
It's okay. Please continue, please. Please continue,
Okay.
sir.
Okay. So my feeling is that the saline water application on the field, of course, it will affect the soil salinity, and it will affect the nearby surface water, and that also could affect the groundwater. Shallow groundwater especially would be affected largely, and that's the case in the Nile Delta. In the Nile Delta, we have salinity in the delta of the Nile. It's because of the shallow water table there and the excessive use of irrigation by surface irrigation and the high evaporation rate. And that actually makes the saline, the water table to be saline. And there, the drainage is very important for that shallow water table areas, and also a proper management and the avoidance of surface irrigation where really you have salinity issues in these areas. So that's really my comment.
Any other panelists will like to supplement or complement, then they are welcome.
Next question.
And then so some of the people, participants, they have raised the hand. We'll give speaking right to them one by one. Before that, some of the participants have asked about the sharing of the presentation, and we'll share the entire recording of this webinar after 3 or 4 days when it will be available to us on our website. And the presentations also in PDF format will share with the participants. And another request has come from one of the participants to get the certificate of participation of this webinar. So that we can issue the certificate on a specific request. We are not going to issue the certificate in general to all the participants, but if anybody needs specifically, then we can issue the certificate of participation of this webinar. So now we'll give speaking right to
Michael Michael Mutitu. Mr. Michael Mutitu, you can speak. Michael, please speak. Yeah. Morgan Umale.
Yes, hello.
Please speak.
Can you hear me? Hello, good afternoon.
We can hear you. We can hear you. Please speak.
Okay. Thank you very much, all the participants. Honestly, it was an exciting and an enlightening presentation from all our presenters. Now, I did not hear so much about reverse osmosis. I'm in Nigeria here. I'm from Benue State, and there's a very big river in Benue. In fact, it's the two major rivers we have in Nigeria, River Benue and River Niger. Now, River Benue is salt water. Most of it's a predominantly farming area. So, and they engage in irrigation. But it is a challenge using the salt water for irrigation. And I know that maybe one method, I don't know if it is cheap, is to remove the salt from the water and maybe use the reverse osmosis. So I would really like any of the presenters to help with that question, because it's a problem here in Nigeria. Thank you.
So
Any of the presenter panelists, if they like to speak?
I could speak, although I'm not an expert on desalination technology, but of course, based on my experience applying saline farming systems, utilizing the reject brine from desalination. So I don't know what is the salinity that we are talking about, but I think, first of all, there are, as Marco already showed, these solar desalination technologies too that could be utilized also to cut down the expenses from energy point of view. So what we have to consider when we want to, let's say, establish a kind of solar, or not solar desalination unit technology in a specific region, we have to take into account the salinity of the water that we want to desalinate. What is the purpose? It's drinking, agriculture, it's both purposes. How we are going to utilize the reject brine? It's not something minor, and especially, and this was stressed out in one of the presentations, I think it was from Engineer Felix, that we have to produce food, but at the same time, we have to preserve the environment. So this is really vital to have these directions and two approaches in our mind at the same time. Also, the socioeconomic context within where these different kinds of desalination technologies will be implemented, and also the farming context that can justify such kind of investment, or what kind of, different kind of investments, even from government point of view, could be deployed in order for such desalination kind of units to be established in some areas. So this is, let's say, my suggestions. As I mentioned, I'm not a desalination expert, but this is what my experience has shown based on my involvement and using the reject brine from desalination. Probably some of the other esteemed panelists could also add, I don't know, Marco or any other. Thank you.
Can I comment on that as well?
Yeah.
Reverse osmosis is one of the methods for desalination. There are other methods, might be cheaper and less energy consuming methods. Nowadays, they talk about forward osmosis rather than reverse osmosis. There are people actually talking about thermo technology to also for desalination. But the issue for me is the following. Why we need to desalinate water for irrigation? Because if you have a saline water, why don't we use it for salt-tolerant crops? To me, that desalinating water for irrigation deserves to have a cash crop to go with it to justify the cost. The cost now of desalination water is almost on average $1 per cubic meter. And unless you grow strawberry and you sell it in Wimbledon tennis tournament in London for $10 a pot, you cannot really get back the cost. So my advice to my African country fellow is, and that's the same advice I said it to my fellow countrymen in Egypt. I said this: unless you have cash crops, don't desalinate water for irrigation. Full stop. Because you cannot make losses, financial losses, by desalinating water to grow barley in the desert of Egypt, for example. You cannot do that. So you have to take the financial consequences of what really you use the desalination water for. Desalination water is expensive, and it has to be justified to be used for irrigation. And also you have to use a most efficient irrigation system that to use the minimum amount of water. And what's wrong with quinoa in Africa? What's wrong with amaranth? What's wrong with barley? What's wrong with sugar beets? All these crops are salt tolerant. And why we don't change our cropping system to include not the classical and the business as usual, to a new cropping system that would allow us to use these salt-tolerant crops without really resorting to use desalination. I only use desalination for irrigation as a last resort, and also only for cash crops. That's my advice.
Okay, thank you, Dr. Ragab.
May I add?
Yeah.
May I add my consideration as well?
Yeah.
Yes, I agree, of course, with what Dr. Ragab was saying. Sounds to me very, very logic and very, very logical. I mean, I can only, I mean, in the video that I was showing in Capo Verde, the farmer decided to pump brackish water by means of these solar panels, and he was growing there with the water he was able to withdraw from the ground table. He was able to grow banana, sugarcane, potatoes, and some other. So this is very true. I mean, unless you're growing cash crops, or you know what the market is indicating for staple food. I agree with what Ragab was saying. So you have to know what is your aim. Unless you have cash crops, of course, it's not worth. I mean, even though as I have been showing, the price today, and again, I totally agree with Ragab, the price is progressively going down for desalination. Of course, the most common technique is this inverse osmosis, but there are many recent research who show that price can even in the future can go even lower. But of course, that is something that is we have to look forward to. So that's my comment on that.
Thank you, panelists, for making a very comprehensive reply to a very complicated question. And it is indeed a very matter of very great importance that we should realize the importance of cost comparison between the various costs of water versus the outputs that we will generate out of that water. So this is a very good takeaway from this particular seminar. Now,
Dr. Suresh Kulkarni, you can speak.
Yeah, thank you. Can you hear me?
Yeah, we can hear you, sir.
Yeah, thank you. I have a question. It's really, for example, in my state, Maharashtra, one of the reasons for low productivity, overall low productivity, is the salinity of the soil as well as salinity of the water, especially of the groundwater. For example, in Maharashtra, something like 15 billion cubic meter of water is used, groundwater is used for agriculture every year, which is something like 90% of total water abstraction, annual abstraction. Now, out of this, something like 30% or 5 billion cubic meter of groundwater is saline. That is, salinity is up to 8.5 pH, or even the EC is very high. So I find that a lot of farmers are facing the problem of salt deposition, because in Maharashtra, which is a leader in use of drip irrigation, there also farmers are feeling a lot of difficulties there. Now, question is, there are some farmers which are really grape growers or pomegranate growers or vegetable growers. They are using some sort of a softener, water softener. I don't know from where they got. They said that they have got from some company from abroad, and they are using that water softener. And they say that after 1 or 2 years, that become ineffective. As a matter of fact, these water softeners are very expensive since they are imported. So I would like to know from the experts, Dr. Marco or Dr. Ragab, that whether such type of water softeners are really there in the market, and are they reliable? Because these water softeners don't work on the electricity, but they say that doesn't require any electricity. So I am really doubtful, and many farmers are really getting some sort of loss of using this, because farmers need this water desperately. So if there is some sort of guidance, it will be very good. Thank you. Thank you very much.
Yes.
Thank you. Can you hear? Yeah.
Any one of the panelists can.
Yeah, any of the panelists would like to reply to Mr. Kulkarni?
Can I ask first what actually that softener is exactly? Is there any composition written on the softener pack? What it is? Is it gypsum, like calcium sulfate? What actually the main ingredient in that softener?
Yeah, sorry, can I speak? Hello? Yeah, it's not a chemical. It is a some sort of a piece of pipe. It is a physical, it is a mechanical device which is fitted in the delivery of the pump. And they say that this is a water softener. It nullifies the ions or something like that in the saline water. So that's yeah.
Yes. But your pipe would be having some chemical compound in it, which will be, while water passing through it, will actually react with it and then have the water softening. So really speaking, it is a chemical that is important, not the pipe.
There is no chemical actually. It is just a physical. They said that there is some magnetic activity takes place and the salt is removed. But that's what farmers are not really very clear about it. But it is a big business going on in Maharashtra.
Well, it is a big business. I think it's. I have seen that in Cairo Water Week in the expo, and I've been trying to get in touch with the developer, who appears to be a German professor. And it is a magnet. Basically, it's a magnetic system. My colleague Marco referred to it in his presentation, and it is reorientation of the ions. But he actually, the professor, declined to give me the exact actually mechanism because he considered that as a patent and intellectual property right to say exactly what it does. But that system goes back to the old Soviet Union. They were reclaiming saline alkaline soil by those large-scale magnetic systems to reclaim the alkaline sodic soils. Now, the soils can be saline not alkaline.
Yeah.
But they can also be saline alkaline. And in order to see whether your soil is saline and not alkaline, it is by the infiltration rate, by looking at sodium absorption ratio, which is AR, and something is called ESP, exchange percentage of sodium. And if your soil has got a high percentage of sodium, then and the pH is high, then it becomes alkaline. And I faced this problem in north of Egypt in my younger days. And what we had to do is we had to use gypsum to plow it together with the topsoil layers and to improve the drainage system. And we had to use actually a vertical drainage system to allow a fast drainage of this actually leached saline alkaline water. And we had to grow sugar beet. And we had to introduce sugar beet at that time, despite the farmers' rejection, because they are getting used to classical cropping system. So what we had to do, number one, is to add gypsum sulfate and to plow and by subsoiler to improve the infiltrability of the soil. We had to improve the drainage system. There was a shallow water table actually helping to increase the salinity in the top layer of soil. And we had to even to improve the drainage by having vertical, like borehole, to allow the water to accumulate horizontally into that, and then we pump it out, that water. So there are some field management to go with the treating that sort of soil. But we have to be careful not to add too much water. Too much water with salinity, you actually add salt to the soil. So if you want to be the most efficient person in the world when dealing with saline water, not use much of it. Use as little as you can. If you add 1 liter of saline water, you add also salt with that liter. So you try to minimize that, improve the drainage system, have a look at the alkalinity, measure the pH, measure SCR, measure the ASP, and see if really you require to add gypsum sulfate to the soil or not. Another thing we did is you plow the organic matter, the residuals of the crops after harvesting, that actually improve also the infiltration. Not only that, but also minimize the evaporation from the soil surface, and by this, you don't have accumulation of salts on the surface. That's what I can say.
Yeah, thank you.
Thank you very much, Dr. Kulkarni and Dr. Ragab, for a very important discussion and in a very important topic. Yeah, please, Dr. Marco. Yeah.
Yes, my coming back to the question that was expressed. This new technique that I was showing, it's based. It's not a software. I would not say it's a software or something like that. It's based on electromagnetic impulse, which is given by a machine, by an apparatus, and this electromagnetic signal goes into the water and changes the structure of the molecular structure of the ions, I mean, and the salt. And besides, it also enhances the capability of exchanging relations, chemical reactions and relationships within the soil. So I could say I'm not really aware of what this technique, this software thing is, but I can tell you that this company, they are based in Switzerland, and actually they have been developing in order to avoid problems of water clogging inside the pipelines, even in for civil purposes, and in order to avoid the problem of solving the problem of nematodes into the ground. So I have been capable, I've been going through some of the works, scientific papers they have been producing, and the results, one of them I showed them was based in Saudi Arabia. I think one of them, sorry, Tunisia. So I think that the results seem to be encouraging. Only problem is the initial cost of this apparatus, which is a little bit high, but seems to be promising. Of course, problem is what happens to the ground table when the structure of the soils is dissolved. So one of the major issues with this innovative technique or this innovative approach is to consider what happens to the soils that, as you have seen, fall down into the ground. So I could talk about this, but I'm not very confident, as Dr. Ragab was saying, about this softener approach. So this is my comment on that, my remark. Thank you.
Thank you. Thank you.
Yeah. Thank you, Dr. Marco. Now we have come to the end of this very informative and a very useful webinar, in which we covered the topic of saline agriculture and water management aspects of it. And it's a matter of great honor for us that we had the very learned presentations from Mr. Boroto, Dr. Marco Arcieri, Dr. Ragab, and Dr. Lyra. We are all thankful to them for having made such very valuable presentations. We are sorry that we could not manage to put Dr. Wahba on the webinar because of various technical problems. But then Dr. Wahba, being very closely associated with the African Young Professionals Forum, he has got multiple other means to really get back to you and communicate to you about his views. So we are indeed thankful to President ICID, Dr. Felix Reinders, who provided us with a lot of enthusiasm and a lot of support in making this webinar a great success. So I thank you all and wish that we will have same kind of presentation and participation from all of you in future. Thank you very much.
Secretary General, just one final remark. Dr. Boroto extends his apologies for he had to leave some minutes ago, so he asked me to offer to you his apologies because he has another important meeting in FAO headquarters. So he had to leave some minutes earlier. So just to,
Thank you. We are grateful to him also. We'll take up with him some other connections as well. Thank you very much.
Thank you.
Thank you all.
Thank you.
Bye.
Thank you very much. Thank you.
Bye.
All the best. Bye-bye.
Bye. Thank you.
Bye.